In this lesson, we're going to look at the solubility of compounds and recognize that some compounds are insoluble in water. We have a set of solubility rules which allow us to determine whether an ionic compound will be soluble in water or not. Remember that these solubility rules only apply to aqueous solutions, so when water is the solvent. We're going to explore these rules by going through a number of examples. First, we're going to look at compounds that are generally soluble in water. For example, when we see a compound that contains a group 1 metal cation or ammonium, NH4+, we know that this compound will be soluble. Note that the group 1 metal cations include lithium, sodium, and potassium, and other metals in that column. We also know that compounds that contain any of the ions CH3COO-, which is acetate, NO3-, ClO3-, or ClO4-, will all be soluble in water, and there are no exceptions to these rules that we need to be concerned about. Looking at the halides, chloride, bromide, and iodide, we'll see that they are generally soluble, but there are some exceptions when paired with either silver, mercury, or lead. Sulfates are generally soluble, except when paired with silver, mercury, lead, calcium, strontium, or barium. Let's look at some examples. First, we'll look at NaCl. Note that NaCl contains Na+. You may need to review the ionic compound structure to recall the charges on the ions. Remember, NaCl contains Na+ and Cl-. Since it contains the Na+ ion, we know that it's going to be a soluble compound. Because there are no exceptions to that rule, we know that anytime we see Na+ in a compound, we know it's going to be soluble. Next, let's look at KNO3. KNO3 contains K+, and it also contains NO3-. Either of these rules show us that this compound will be soluble in water. Therefore, we say this is a soluble compound. PbNO3, too, which is known as lead nitrate, contains NO3-. We see that the rule for NO3- does not have any exceptions to the solubility, therefore this is a soluble compound. AgCl contains chloride, and chloride compounds are generally soluble. However, compounds with chloride and Ag+ are an exception. So once we see the Ag+ in there with the chloride, we know that this is going to be an insoluble compound. MgSO4, or magnesium sulfate, is our next example. Sulfate compounds are generally soluble, and magnesium is not listed as one of the exceptions. Therefore, this is going to be a soluble compound. Next, we'll look at BaSO4, or barium sulfate. We know that sulfate compounds are generally soluble. However, we see that barium 2+ is listed as an exception, and so since it's an exception to the solubility rule, we know that this compound is going to be insoluble. When we see compounds containing any of the species in the left-hand column, we know that they are generally soluble. There are exceptions to these rules that you do need to know. This includes both the exceptions for the halides as well as for sulfates. Now we're going to look at a list of insolubility rules. Compounds that contain the ions listed in the left column are generally insoluble, except when they're paired with one of the species listed in the right. These are the exceptions to the insolubility rules. Let's look at some examples to help us understand how we use this information. Na2CO3, or sodium carbonate, contains the Na plus ion. Even though carbonates are generally insoluble compounds, sodium plus makes it an exception, therefore this is a soluble compound. Calcium carbonate contains the carbonate ion, which is generally insoluble, and we see that calcium is not one of the exceptions, therefore this is an insoluble compound. MgOH2, or magnesium hydroxide, is next. Hydroxides are generally insoluble, but there are some exceptions, but magnesium is not one of them. Because it contains the hydroxide and magnesium is not an exception, this is going to be an insoluble compound. Barium hydroxide also contains OH-, which generally indicates an insoluble compound. However, barium 2+ is an exception, so when hydroxide is paired with barium, it's going to be a soluble compound because it is an exception to the insolubility rule. AgNO3, or silver nitrate, contains the nitrate ion. Remember from our solubility rules on the previous slide, if it contains nitrate, it's always going to be soluble. We also see this in the last row of the table, that silver compounds are generally insoluble, but when paired with nitrate, we get a soluble compound. PbCl2 contains Pb2+ ion, and we see that Cl- is not one of the exceptions listed on the right column, therefore this is going to be an insoluble compound in water. Is PbI2 soluble? Compounds with iodine are generally soluble, but when paired with Pb2+, it is an exception. Therefore, this compound is insoluble in water. Is MgS soluble? Note that S2- compounds are generally insoluble, and the exceptions are for group 1 cations or ammonium or barium. Because it's paired with magnesium, it is not included in the exception, and so we see that sulfides, in this case MgS or magnesium sulfide, will be considered insoluble. Is AgClO3 soluble? Compounds with ClO3- are considered soluble, and there are no exceptions to those. Therefore, this will also be a compound that is soluble in water. Is CaSO4 soluble? Sulfate compounds are generally soluble, and there are some exceptions, and calcium is one of them. Since calcium is an exception to the solubility, we see that this compound is insoluble. Is NH42S soluble? Compounds with NH4+ are considered soluble, and we see that there are no exceptions, therefore this will be a soluble compound.